Good morning, students. Previous class we have done verification of Ohm's law experimentally. Today let's start combination of resistors. It is quite natural that in any organization or for domestic purpose you will find that more than one appliances we are using. If we are using one appliance, then naturally we show one resistors easily in the circuit. But suppose if we are using more than one appliances, then how we will connect it? That is the main problem. So let us see how we will connect it. Connection is being done by two processes. First is series combination that we are going to study, and second one is parallel combination that we will study later on. So first let us see series combination of resistors. Students, then how should we understand that which one is series combination? Series, it is in series. Series combination is also known as end-to-end combination. End-to-end connection or combination. Then what do you mean by end-to-end? Yes, just see, I have shown here one circuit. It has two resistors. First end is connected to cell of positive terminal. Second end of R1, that is first resistors, is connected to first end of second resistor. Again, if we take more than that, then second end of second resistor will connect it to first end of third resistors. That means end of one resistor, again first end of another resistor. So it is also known as end-to-end connection. Then again, for this we have to think that there is only one path for the flow of current. That means whole circuit, the current will flow in one path, current will not divide. How it will not divide? So I am showing you here. Here R1, one resistor, R2, another resistor connected to cell. As the current passes, suppose this cell giving I current. So as I is passing through this directions and it enters in R1 and again it comes out, that is same I. Again it enters to R2 and it comes out in the circuit, that is I. So whole circuit you are seeing that I remains constant, that means current remains constant. Whatever, wherever you will take it. And for this current there is only one path so that it will flow. Ohm's law we have studied V is equal to IR. So let us think about V. Because I is constant, R is varying. Suppose one we have taken light, another we have taken fan. Naturally the resistance will vary. Potential difference, whatever the potential difference R will consume or R1 will consume or R2 will consume, when it will come, again it will gives V. So if for R1 it is V1, for R2 it is V2, then we can write V is equal to combination of V1 and V2. Or according to conservation of energy even, that whatever the potential it is applying, differences it is applying, naturally it will get the same it does not bother about what the R1 has got the V1 or what the R2 has got the V2, but whole circuit, whatever the V is, combination of V1 and V2. So let me write, this is equation 1, this is equation 2. V1 for R1, let me denote V1, we can write it as IR1. V2, IR2. When we combine both this, that means put the value of this V1 and V2 in equation 2, we write it as V is equal to IR1 plus IR2. As the current remains constant, we can write this one as I and take the common I, R1 plus R2. From the Ohm's law, V is equal to IR. So we can write this one as here. So IR. Now, what this R? This R is equivalent resistance. I am writing over here EQI. R equivalent resistance, or you can say total resistance for this circuit. We are not bothering about R1 and R2 now. We are taking out the equivalent resistance for the circuit. So IR equivalent is equal to IR1 plus R2. I is constant, so we cut it I and I. So what we have got? R equivalent is equal to R1 plus R2. This is the total resistance or equivalent resistance for the circuit. This is circuit. Now let us find out the conclusion for this, what we are getting it. So what conclusion we will get it? First of all, we have seen just now that the current is same in whole circuit. The current is constant. Next, you will find that the equivalent resistance is sum of the individual resistance. If individual resistance, suppose the maximum resistance value is 5 ohm, then naturally equivalent resistance will be greater than the greatest individual resistance. Next you come, current in the circuit is independent of the relative positions of resistors. Wherever you are keeping the resistors, it is not showing that it varies. The current will pass through each resistors and that will remain same. Next you come, the potential drop across each resistor is proportional to its resistance. If R will be more, then it will consider. If R will be less, then it will consider. So here today we will do up to here only. Then next let me show you the parallel combinations. Now I have taken the circuit which consists of two resistors R1 and R2. Students, first thing you remember that in parallel combination there must be two common points. Here you will see one common point we have, suppose X, and another common point we have Y. X is connected to positive terminal, Y is connected to negative terminal. Again, that is the same problem, how we find that it is parallel combination. So first point you have understood that it has two common terminal, whatever resistors is there, means whatever number of resistors is there. Now when potential difference is applied, current started flowing? Suppose I started flowing when it comes to the common point X. Then this I, where it will go? Either it will go for R1 or it will go for R2. At that case, what happens? That I divides whatever current or whatever value of R1, it will take that proportionality, its current in this branch, and so let it be I1. Again this I divides for R2 and let it, the current will be I2. And again I1 is coming from this direction, I2 is coming from this direction, I1 and I2 both combines at the common point Y, and again in the circuit you will get I. So here what changes you are getting? We are getting this one, that I divides in two parts, because two resistors I have taken. If three resistor I will take, then it divides in three parts, four parts. So I vary. One conclusion we have got, I vary. Naturally R1 and R2 are varying, that is R1 and R2 both are different because we are taking different appliances. And for this case, V remains constant. Whatever the potential difference for R1, same potential difference for R2, whatever it has given V in the circuit by cell. So we have got this conclusion. Now again, let us apply Ohm's law. We know Ohm's law is equal to V is equal to IR. Here I we can write circuit current, or you can say we can write I is equal to I1 plus I2. I1 from Ohm's law, that is V is equal to IR. So we can write I1 is equal to V by R1, and I2 we will get V by R2. Suppose this equation 1 and this equation 2. So here, applying the value of I1 and I2 in this main equation 3, what we will get? Just check it. I is equal to I1 plus I2. I1 is V by R1. I2 is V by R2. And I from Ohm's law, we can write it as V by R equivalent. R equivalent is for circuit resistance, equivalent resistance. V and V take common. V 1 by R1 plus 1 by R2, and this way by R equivalent. As V is same, we cancelled it, and so we got it. R equivalent is equal to 1 by R1 plus 1 by R2. This is the formula of parallel combination. If suppose more than two resistors we will connected it, then that much number will be there. So if suppose n times resistors we have taken, so we can do it as 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R up to last 1 by Rn. So students, up to here, write the conclusion for this and send me in class group. Okay.